All right, this next topic is on Amsoil 5w-30. It's called a white paper. It's a test done by Amsoil, and this is one of the ones which we're quite familiar with as Amsoil people, because it's where they select a group of oils, they do some uniform testing, and by the way, this testing was all done by a third party. This testing was not done by Amsoil, it's done by a third party test. Now, I can tell you where Amsoil usually does that, but I can't tell you exactly which lab did this one. They usually go down to San Antonio and they get the, what's the name of that?
Southwest Research.
There we go, thank you. Southwest Research Lab, who does the testing for NASA, the Air Force, the Army, and the Navy, where they certify different components for those organizations. This is an organization that Amsoil could not pay enough billions of dollars to persuade them to change anything that comes out of their testing. In other words, they're going to test it. If you don't like it, get somebody different the next time, because their reputation is more important to them than anybody hiring them to test products, okay? And that's the reason why Amsoil has used them. So, 5w-30 Signature Series. And I bring that out because one of the things that has come up several times to me in the last couple of months, and I say this and hopefully people that see this on YouTube will understand it, Amsoil has 3 families of oil. Please don't compare apples to oranges and tomatoes to cucumbers, okay? Amsoil has a Signature Series oil. That is the top of the line premium oil. It's the original Amsoil, made to the highest possible standards they can figure out how to make it. If you don't want the best, don't buy Signature Series, okay? They have an intermediate oil, which they call XL oil. This confuses people sometimes because they think that must be the extra life one that would go the greatest distance. I'm sorry, I didn't like that name. I still don't, but we have to live with it. It's called XL oil. It's a 10,000 mile, 1 year oil. Very good oil, but it doesn't hold a candle to the Signature Series. There's a new oil that Amsoil has. It's called OE oil. OE oil is a standard synthetic in the same vein as Kendall, Castrol, Syntec, these different standard synthetics. Is there anything wrong with OE? No. It's a competitive oil. It's a very good oil. But you need to know that you're going to pay for what you get. The OE is the introductory oil at the lowest price. The XL is in the middle. And the Signature Series is at the top. Now, most people, once they have anything to do with Amsoil for a couple of years, gravitate to the Signature Series, because it's like going from a trailer tire to a high-performance Pirelli radial or something. I mean, it's like, okay, once you finally put those high-performance Pirelli radials or Michelin radials on your car, you probably don't go back to the bias ply trailer tire that you could put on the car. Yeah, both of them roll, but it's not nearly the same. So the point is, Signature Series is the top of the line. This is 5w-30 Signature Series oil that we're going to talk about. Now, the test that was done is not as comprehensive as we've seen in the past with every possible way you can test oil. They picked out some things that each oil really needs to be able to do, prove that it can do it, and that's easy to compare between them. One of the tests is called the 4-ball wear test. Then we have the total base number test. Then the cold cranking viscosity test. And then we'll just call it an oxidation test. They have a longer name for it. And the NOAC volatility test. Let me take just a minute and explain those tests, and then we'll run down through how the test worked out. 4-ball wear test, developed by Shell Oil Company. Got nothing to do with Amsoil. It's been around for a long time. It is a test which is designed to give you an indication of the strength of the oil film. Remember, we talked about earlier in sessions about how oil film is what would keep 2 metal surfaces separated. That film of oil keeps them separated, right? If that oil film starts to break down, we go into what's called boundary lubrication, then our additives prevent wear and scarring, okay? Now, I need to have some way to determine how strong the oil film is and whether I've got a pretty good additive package to protect moving parts. So what Shell came along with, and I will represent this to you, I don't have a picture of it, but what Shell did is they decided, okay, I'll have a cup, I'll put 3 ball bearings in the bottom cup, and this cup is, say, got a depth to it, lower than the ball bearings, and I fill this with oil. Then I put a 4th ball bearing sitting on the top. So I've got 4, that's why it's called the 4-ball test. I've got 4 of them, 3 in the bottom, 1 on the top. Now the bottom thing here can spin, okay? It can spin. The top piece that comes down is going to hit on that top ball, and I'm going to apply pressure down against this while spinning the bottom cup. Now the only thing that protects these bearings is as these bearing balls roll, they pull oil up out of the cup and bathe themselves in the oil. That's it, just the oil. So there's nothing else going on here except oil rolling over them, right? Now, in order to test this, and the ASTM, American Society for Testing Materials, certifies the test, it has to be absent of any human coercion. I can't change the test because I'm doing the test versus somebody else doing the test. The machine will do it, and we can't alter it by who's doing the test. So what you do is you turn the cup at a certain RPM. This test was done at 1800 RPM, the cup is turning. So all these balls now are moving because that cup is turning at 1800 RPM. Okay, I'm going to put so much pressure down on it. This particular one, I believe it's, is it 40 or 60 kilograms? Anyway, it's 40 or 60 kilograms coming down. We'll get to it in a few minutes, it tells us. That's the pressure that's applied, and now I have to have this whole oil bath at a certain temperature. Doing this one at 150 degrees centigrade or about 300 degrees Fahrenheit. There's a reason this test is being done at these parameters. That's almost twice the normal parameters that you test oil for a 4-ball wear test. And the reason is you really want to know if this stuff's any good. Let's put it to the most rigorous test and see how it performs. Okay, now once I run this thing for a set amount of time, I stop, I take these ball bearings out, and they are actually inspected, and the width of the scar, because you're not going to keep them from, they're eventually going to go metal to metal. The width of the scar is measured, and it's how big that scar is. Of course, the smaller the scar, the better the oil. That's the 4-ball wear test. So we'll get to that in a few minutes.
So you're saying is the balls are actually going to go score?
Oh yeah, yeah.
Score.
Well, it's one of the reasons, quite frankly, we go to 150 degrees and 1800 RPMs and the pressure we do, because there's a couple of oils, Amsoil in particular, that you can't scar in the original test. Okay. It will not break through. When you have 75 degrees, 1200 RPM at 40 kilograms, you never break through, so you can't even measure scar on Amsoil. It will not scar.
So what caused the scar then? I mean, if it's bringing the oil back up through the system.
No, what happens is these balls pushing on each other, the points, they're round, right? Yeah. So I'm going to have this round surface going against each other at these points. When the oil film can't stop due to the pressure and the temperature, the balls from touching, okay, what happens is they'll scar because they do what they call high pressure spot welding. They literally try to spot weld and they break loose and they make a little scar. So the size of those scars will tell you how well the oil film worked. Now the next test is called the total base number test. That's easy. Total base is defined as the ability to neutralize acid. So the higher the number, the more acid it can neutralize, and also the higher the number, it reflects the quality or strength of the additive package. The higher the TBN number, the more robust the additive package in the oil. Okay? Next one was cold cranking viscosity. Again, this is easy. I take it down to a cold temperature, and let's see what kind of viscosity I got at that cold temperature. That's going to tell me how hard it's going to be to start. So I cool all the oils down to the same temperature, and I measure the viscosity using a cold crank simulator device. Okay? Then the oxygen uptake type test. This oxidation test is straightforward. You heat this oil up, it's got a bad problem. The hotter oil gets, the more it will react with oxygen. We're just going to simply see how bad it will react with oxygen. So it's an oxidation test. Okay? And then what's called a NOAC volatility test. The NOAC volatility test can be described as a vaporization test. I take so much of a liquid, I heat it to a certain pressure. I've got what they call a testing device that has all the liquid in one side. It has another empty chamber here. I heat it, hold it at a temperature for so long, I take it, and I look and I see how much became vapor and went into this chamber and how much is left. If I started with a certain volume here, I'm going to see what percentage of it vaporized and ended up in the other chamber and how much liquid was left here, okay? It tells me how volatile the oil is, how easily it turns to vapor, or how much it resists that under high temperature, okay? So these are the tests that should be straightforward, easy. There's no confrontation on these tests. They're well accepted throughout the industry. Everybody knows how they work. You can have any lab run these tests. How's it going to turn out on these different oils, okay?
I got a question.
Just a second. Yes, sir.
Trying to visualize this cold test. I mean, do they bring the engine down to a temperature and try to fire it?
No. Let me give it to you. There is a cold crank simulator, but what they're talking about here is when I measure the viscosity of a fluid, I have, for the upper temperature in oils that will be measured at 210 degrees, I have a viscometer, it's called, where what I really do is I heat up a volume of oil, I put that volume in this chamber, I have an orifice which is designed to a certain size here, the oil starts to pour through that orifice, I time it. They used to call them Sebald unit seconds, okay? And what it was is how many seconds does it take for this chamber, this volume of fluid to drain through this all the way. I time it, that kind of tells me how thick it is, right? That's the upper limit. That's not what I use though, Marty, for the cold crank simulator. Cold crank simulator takes a little cup, if you will, and under it, it has what they call a magnetic stirrer. What that means is down here I have a little thing that rotates a magnetic field, and I put a ferrous magnetic slug in this cup of oil.
Okay.
Now that little rotating of that machine is going to try to pull that slug around in that thick oil, right? Now you're going to love this. This is how we test this. I have a highly accurate small milliamp meter. The amount of current that it takes to move that slug on that magnetic stirrer on this highly accurate amp meter, I can only fall between a certain range of amperage to classify the oil as a certain viscosity rating for cold crank simulator.
Okay.
And that's how the test is done. So what it's really doing in one case is testing how well the oil flows, right? But in the other test, it's actually testing how easy can I move a device through the cold oil, because that's what an engine does. An engine has to start trying to move its parts through this thick oil. So I want to know, with this little device, it gives me a way to determine the internal resistance to a moving component in this oil. And that's why it's called a simulator, because it doesn't really measure viscosity. It is called apparent viscosity instead of true viscosity. So that's the difference. All right, good question. All right, now, in these things that we tested, it may not be easy for everybody to see, but this is Amsoil Castrol Edge with titanium fluid strength, Lucas Synthetic, Mobile 1 Extended Performance, Pennzoil Ultra, Petro Canada Supreme Synthetic, Quaker State Ultimate Durability, Redline High Performance Motor Oil, Royal Purple High Performance Motor Oil, and Valvoline SynPower. Those are good oils. I mean, let's give them credit. Those are all a good range of oils, and people buy lots of those oils, and they're probably pretty well happy with them. So we're not saying any of those oils are bad. Any synthetic is probably hands over usually better than any petroleum. But the question is, when you start comparing the synthetics, which one starts to come out? It's kind of like comparing radial tires. You know, they're all radials, but which one's going to perform the best? Now this is the 4-ball wear test and the indications that you can see here. And as I said before, once I explain the test, I really don't have to go into a lot of great detail. You can see on the bars that, I better bring it up where we can read them. That wouldn't hurt. There we go. And if it's hard for you to see them back there, Amsoil over here at about 0.38, somewhere around that, on the 4-ball wear test is the lowest one on the left. The next one to that is the Lucas Synthetic, then Valvoline SynPower, Royal Purple High Performance. Actually, any of those under 0.4 are doing a good job. Amsoil's the best there, but if you stay under 0.4, you're doing a pretty good job with the 4-ball wear test. What's really not doing a good job is those 2 high markers you see over to the right. These guys need to go back into the control room or something. And that's the Castrol Edge with titanium and the Mobile 1 Extended Performance. Now those are expensive oils in the marketplace, considered good oils. But their 4-ball wear test would indicate they don't have the film strength, especially under high performance or severe duty, to really protect and prevent wear. Okay, now these other guys, not too bad. But here's the point in this test to understand this. These oils are going to move places. The last place guy ain't going to be the last place guy in the next test. So they're moving around. So some oils, sometimes they formulate them, they want to accomplish something, and they leave the other part for history. They didn't accomplish it very well. The idea is to find an oil that tries to accomplish all of these things in good stead, the best it can, without having one outlier where it just falls off and doesn't perform. Okay? So that's the 4-ball wear test. Now this is the total base number, and listen, this is simple. This doesn't mean that the oil had to perform in a certain way. This is just testing to see what the additive package was. Either you spent the money to put it in or you didn't. Okay? It isn't a matter of whether you could or couldn't. Anybody can. You just have to add the chemistry to get where you want to go, and it costs money. And what we see is this is Amsoil here at about 13, and next to it is the Castrol Edge with titanium. Got a good additive package. Just what are they doing with that outlier where they're, I don't know. But anyway, and it works its way all the way down to the lowest is the Lucas synthetic. Remember, Lucas was way over here before on one of the other tests there. So these guys are, yes, Ricky.
Would the 4-ball wear test and the total TBN test that we're looking at now, would that basically, okay, Castrol Edge has better additives, but would that consider their base stock not as superior?
Well, here's the thing on that. Actually, you bring up a good point. Is I would question why Castrol Edge would have such a good TBN, okay, but their actual was it the 4-ball wear test on them? They were way over. Yeah, why they would? Because typically, if you have a good quality additives, the TBN will reflect a very good 4-ball wear test number. They had a high TBN, but not such a good 4-ball wear test, and I'll tell you what I think it is. Normally we get TBN from the zinc dithiophosphate, as it is used up as an anti-wear product, its residual raises TBN. So you would say, okay, well I got this, if I got a lot of this anti-wear additive in here, it's how my TBN is high. That's not true anymore because I can't put all that stuff in there. So I have to find an alternative chemical to raise my TBN other than the anti-wear additives that used to do it. So all of a sudden it's, what did you buy? What are you using to have a high TBN that's not also helping you with your anti-wear situation? And I don't know. That's a proprietary thing of what they're doing. Now I will tell you on the oil analysis I've seen, and I saw a bunch of them that Marty and I looked at, I will tell you why Amsoil did really well on both of these. They're adding, we saw it right in there, and Amsoil they don't make any announcement on this, but that's 150 parts per million of organic moly sitting in that 5w-30, and the oil that we saw, 10 or 15 oil analysis, and every one of them had 150 parts per million of organic moly. That's a very expensive product that is apparently being added now to make up for the lower amounts of zinc and phosphorus required by the EPA. So that's an expensive move, but it apparently is working very well. And when we get to the taxi cab test, we'll see how well it's working. So okay, that's TBN. That's a matter of what you want to spend and what you want to put in there. Now we come to the cold crank simulator viscosity. And what we see on here is Amsoil again, looking good. These guys are doing okay. Any of these guys down in here are fine. If you start to get here, you're not getting the bang for your buck for buying a synthetic for starting up real quick. It should be giving you a better 5W rating. And who is this guy? You see there we have red line now is way over on the right. There may be a reason behind that because red line really does really well on high temperature, real high temperature, and they may be using some larger molecules to accomplish that. And it shows up, it grabs you in the tail when you get to the cold crank simulator. But when you're making primarily racing oils that Redline makes, I don't think they worry too much about cranking up in the Arctic. They worry more about 500 degrees on the racetrack. So in their defense, they wouldn't expect to do real well on a cold crank simulator. They would do better on high temperature testing than that. So some of these things, you need to give them credit for where credit belongs.
This is So you're saying basically they want to excel somewhere, not necessarily.
Yeah, they don't care about the cold crank. They want to go on the racetrack. See, that's one of the things to remember too, folks, watching this video or anybody else, is that oil companies will go in a direction. Redline's a high performance racing company. In their defense, they don't really care if the oil cranks up well at low temperature. They're more interested in high performance racing applications. Our 5w-30, we care. This is an all-purpose consumer oil product we're making here, not a racing product. Okay. Now in this one, the oxidation test, look, we get beat by Amsoil Edge with titanium. Now remember, they were one of the guys with the high bar over there one time before, but now they're over here looking good, so give them credit for that. But again, we're second. We're right down there in that category, in that group. So we're talking about an overall oil, and we're not winning every single category. It's kind of like a golf game. Some holes you win, some you lose. What you want is the lowest score. Okay, so this is oxidation. Now, who is this guy that really went? Oh, now there's not a good reason for that in a racing oil. You still want to avoid high temperature oxidation.
With high temperatures, you don't want your oil.
You don't want it to turn into gunk before you can finish the race. Okay. Oops.
Just tap it, Dan.
I know, I hate this thing. I'm no good with this on the computer. Okay, now, no volatility. This is Redline, Amsoil, and here's Amsoil. Now, remember I told you Redline could be using some bigger molecules? Bigger molecules do not evaporate as easy. So it shows up that they're a little thicker, a little harder on the cold crank simulator, but it also shows up that they don't vaporize as much because they're using a bigger set of molecules in order to produce a racing oil. Okay? Now, Amsoil is down in the vicinity. This is 7%, so they're right around 7 on this. Now, why no volatility is actually important to you is that oil starts to vaporize, it begins to thicken. And so what we're trying to do is make sure that we start with a 30 weight oil, and at whatever time we tell you to change that oil, you still got a 30 weight oil. We don't want to be a 50 weight oil by the time you change it because we got such high volatility, because in high volatility, usually vaporizing off what they call light constituents of the oil, and the heavier molecules are staying at home, so it gets thicker and thicker and thicker. Add that to a bad oxidation test, and you got thickening from oxidation and thickening from volatility, you're headed for trouble if you run it too long. So since Amsoil says this oil is good for 25,000 miles or 1 year, they need low volatility and low oxidation stability because they want this oil to stay in grade for up to 25,000 miles. So you have to engineer it to do that. Okay, let's see, where are we now? Now, this little table here reflects cost, because one of the factors you have to always put into when you're buying a motor oil is just how much does this stuff cost? Because we could develop this motor oil the way, when I was in the military, we used to say the United States Air Force was going. Eventually, they were going to buy, for the entire Air Force budget, one fighter plane, but by golly, that fighter plane would do everything in the world. But it'd be one plane that would cost $100 billion, okay? Because that's the way it seemed to be going. Everything was getting more expensive. So there's a limit to how much money you can expect to spend. You can't go out here and spend $50 for a quart of oil because you think this is going to be the best thing. It's just not practical. So you have to figure out how much is this stuff going to cost me and what's my return on investment of cost. Is this thing working out? So we look at this chart, and it lays it out for us. It might be a little bit harder to read, but what we've got is the price per quart, the price for an oil change, and how many oil changes are conducted. Now that's the one I wanted to explain to you. It says here 11,318 miles. Because what they did is they took the actual average mileage per year right now in the country of 11,318 miles. Now, I don't know where they got that figure, but that's the one they used. So they're saying if that's how far you're going in a year, because remember the Amsoil limit? 25,000 miles or 1 year. So they didn't cheat and say, well, Amsoil can go 25,000 miles, so it'll go 8 oil changes, and yours only goes 1. They said, okay, in a year when we have to change ours, how many times would you have had to change yours? Well, at the standard recommendations of the other companies, 2.37 times. They will do 2.37 oil changes in 11,318 miles. or 1 year. And Amsoil did 1. So we back up. The Amsoil is $10.15, it's $50.75. I did 1, it cost me $50.75 of oil for the year. That's how that works. Now, I don't want to stick in that chart for a minute because I want to go to the one that's easier to see. Because they made a bar graph out of it. This one's a little easier to see. Based upon the price per quart and 5 quarts and what it would cost you if you did 2.37 oil changes or 1. Amsoil is $50. The closest to it was the Lucas at $92.55, then $94, $107. You can see the chart, it goes right up. Well, that's not hard to figure out. They're doing 2.37 oil changes to Amsoil's 1 oil change. So that cost comparison takes no kind of rocket science or heavy debate. It just says, yep, you did 1, cost you that much. We had to do 2.37, it ends up costing this much. So if you have an oil that is affordable, because the pricing of it, it goes for a year, and it ranks as the top overall all with all the tests, you're onto something. So in the conclusion that they put in this little white paper, it doesn't take a lot of analysis. I mean, you can see where this goes. In 3 of the 5 tests, Amsoil was number 1. In the other 2 tests, they were 2nd and 3rd. They're the overall best rated oil. And then you go to how much does it cost you to use this overall best rated oil? Well, it's the lowest one to use. It's the most inexpensive. So for us, people in the Amsoil business, we need to continue to emphasize to our customers and the people that we deal with is that you get the best bang for your buck with Signature Series Amsoil, by far. You don't get the best bang for your buck with OE or with XL. You get the best bang for your buck when you buy Signature Series. Now, what does that mean? Does that mean that all these people I'm talking to that look on YouTube, everyone's going to run out and buy Signatures? No. What it means, though, is that as you bring your customers into understanding synthetic, and they have a bridge product like OE or XL where they get used to it and they say, this is a good product, this really works. Eventually, they're going to look at this and say, well, why don't I go up to this Signature Series? It's really the best oil. And so there's always a progression moving along. But as a person giving advice to people buying motor oil, you need to always keep in mind, just stick with the facts. The Signature Series is the best oil. Is it the right oil for each person? No, because we go back to tires. Marty sold lots of tires. If I buy an 80,000 mile radial and I only drive 7,000 miles a year, it will dry rot before I wear out the tread. So that's not the tire for me. So sometimes you'll have somebody comes in and says, I only do 7,500 miles a year, I only do maybe 8,000. You know what? XL is a wonderful product for you. It is. Look at how the people drive. Now you got a guy comes in and says, yeah, you know, I just got this good job. I'm a salesman. I'm running all over the state of Florida. I'm probably doing 50,000 miles a year. You go, you know what? You just need to use the Signature Series because not only is it going to go longer, but it's a lot less aggravation to you getting off the road so often to have to go get oil changes. Use this oil, it'll take care of you. So that's how you want to think about these families of oil, is that Signature Series is absolutely the very best. Some people that just don't have the mileage or the need for it, but never let that interfere with what you actually know is the very best of the 3 families of oil. So